So here we have 3 points A, B, and C whose position vectors are given to us. We need to show that these 3 points A, B, and C forms an isosceles triangle. Okay, let us begin. So first what we'll do, we'll consider a triangle with vertices A, B, and C. Now, in order to define the position vector of the vertices A, B, and C, we're going to consider a point O lying outside the triangle, and it is going to be the origin. So here it's given that the position vector of the vertex A, which is OA vector, this is 2i cap. Position vector of the vertex B, that's OB vector, it's given by negative I cap minus 4j cap. And position vector of point C, that's OC vector, given by negative I cap plus 4j cap. Fine. Now, using these three position vectors, we will find out the vector AB. Now, vector AB can be easily obtained by using the position vectors. So we have OB, the position vector of the endpoint, minus the position vector of the initial point. So we have OB vector minus OA vector. Let's use this value. We have negative I cap minus 4j cap. And from here, we are subtracting OA vector. So that's 2i cap. And this is going to give us negative 3i cap minus 4j cap. Now that we have vector AB, we can also find out its magnitude. Also, magnitude of vector AB, that's going to be equals to, we'll take the square root. Underneath the square root, we take the component of I cap, that's negative 3. We square this value and add it to square of the component of j cap. So that's negative 4 squared. This is going to give us 5. So that means AB has a length of 5 units. Next, what we'll do, we'll try to find out the vector AC. Now, AC vector, that's going to be defined in terms of the position vector as OC vector minus OA vector. Now, what is OC vector? That's negative I cap plus 4j cap. And from here, we're subtracting a vector, OA vector, so that's 2i cap. This is going to give us negative 3i cap plus 4j cap. And here also, we'll try to find out the magnitude. And the magnitude of vector AC, that's going to be equals to, we'll take the square root. Underneath the square root, we need the components of I cap, square this value and add it to square of the j component. So this also gives us value 5. Now here we see that in the triangle ABC, the adjacent sides AB and AC has an equal length of 5 units. So that means ABC is going to be an isosceles triangle. So we can say, since the magnitude of side AB equals to the magnitude of side AC, this simply tells us that ABC is an isosceles triangle, and this proves a problem.